Welcome to Lab Life with the Air Force Research Laboratory.
Hi, I'm Michelle.
And I'm Kenneth. Today we're joined by Dr. James Christensen, who's crawled through airplane wings as part of his day job and had a C-130 wing delivered to his cubicle.
In 3, 2, 1.
So to kind of get things straight before we begin, how do you describe your job to your friends and family?
So I describe it as I'm an advanced development project lead. So I am trying to pull together different technical capabilities into products that have value and meet a need, from an Air Force perspective. So I'm kind of in between, I don't do the basic research, but I need to be aware of it. And I work with outside companies a lot to deliver that sort of tangible product that solves a problem for the Air Force.
You mentioned beforehand, or mentioned to us at least, a kind of unique position. So how did you get to this point, or how did your career lead to this?
I was trained as a psychologist, actually a cognitive psychologist or research psychologist, and then further specialized in psychophysiology, which is understanding what physiology is telling us about what's going on in the brain and how a person is doing. So I started working for the Air Force Research Lab right after I finished my PhD, initially doing cognitive workload assessments for pilots primarily. Over time, that has kind of expanded as the technology has really matured to be able to use wearable devices, wearable sensors, small, lightweight technology that's very much applicable to continuous use and field operations. And with it, my role has kind of grown and shifted from, I started out with a fairly narrow focus. I was a bench level scientist for the Air Force Research Lab, into where I am now, which is I kind of lead, develop, manage projects, again, primarily advanced development 6.3 work that pulls together a number of different capabilities, from physiology to gas phase sensing to different electrical things like electroencephalography. But all of it really centers on understanding the state of the airmen, what are they capable of, and helping them to sustain and enhance their performance.
What would be an example of the cognitive workload assessments that you did for pilots? What are you having that do multiple tasks at the same time and see where things break down, or how does it work?
When I first started doing that, a lot of it was about different cockpit interfaces and systems. So, for example, one fairly big project that we did involved a new heads-up display for the C-27. The heads-up display was hard to see, quite fundamentally. And the question that kind of came back to the research labs was, how bad is that really? And that's a cockpit workload question. It's like, okay, if you can't see your HUD very well, you have to work harder to get all the information that you as a pilot need to fly the aircraft successfully. So we designed and executed a field study where we looked at how did the pilots rate their workload. We did look at physiology, how stressed are you as you are trying to do different phases of flight? So how fast is your heart beating? How hard are you breathing? How sweaty do you get? And then compare kind of the new heads-up display to the old heads-up display and see, okay, how much of a difference is there here? And do we think it's an issue for their ability to safely operate the aircraft? So that turns into a recommendation, a report, that we made back to the program office that said, it really is a problem. We are seeing, significant impacts on pilot performance, and so they ended up fixing it. Relatively simple fix. They moved where the heads-up display was mounted, so it was easier to see. It solved a problem for the Air Force. So I think, even though that was, relatively limited in scope, it kind of foreshadowed, some of the things that I grew into later in my career, where we're trying to solve problems for the operational Air Force.
And speaking of that, moving in your career, did you ever see yourself working in confined space monitoring?
Great question. So, as I mentioned, I started out doing primarily pilot work, and the organization that I was in did essentially no work at all with maintainers. That was just not really part of our portfolio. So It really wasn't until about 3 years ago, the Air Force Sustainment Center reached out to the labs and said, hey, we need help with this. We think there's an opportunity here, but it needs research and development. Can you help us out? That was really the first time that I was engaged at all with the maintainer community. And yeah, what they brought to us was a lot of concerns about being able to maintain our aircraft, keep them flying, keep them in the fight, as much as possible. So this directly gets at mission capable rates, which is, of huge concern to the Air Force, particularly with aging aircraft and high deployment rates. So the opportunity that they had was, we think we can make confined space maintenance at the maintenance depots more efficient, reduce the amount of manpower required by using wearable sensors to fulfill some of what human monitors do right now. But what they were basing it on was a pilot project that Lockheed Martin had developed in a very different environment. So the research need was, how do we take something from a very different environment, adapt it to Air Force needs, and then prove it out, demonstrate that it actually works. So I really started from scratch trying to understand how Air Force maintenance works and what confined space maintenance is and the regulations and the procedures associated with that. It was a fire hose learning process for me.
It had to be crazy.
It was nothing I'd ever dealt with before. Unfortunately, we had great engagement and support with the Sustainment Center, and then, very quickly thereafter, Warner Robins, Air Logistics Complex, came on board as well, and they were very supportive of us coming in, working with them, understanding, how this works now, and what we would have to do in order to field new technology that would make it easier, more efficient, while maintaining or enhancing their safety.
And could you create a visual, a mental visual for our listeners about what a confined space is when you're talking about maintainers or people that work on aircrafts and keep them flying?
Absolutely. So at the depot level, this is sort of your major aircraft renovations here. So it's not just, changing a tire or patching a hole. They'll strip all the paint off an aircraft, they'll pull the wings off, and they're doing major upgrades and modifications to it, and kind of completely overhauling the aircraft. In the course of doing that work, a lot of it is hands-on touch labor inside spaces that are really not designed for human habitation. So, for example, a lot of the work that we've done is with the C-130 squadron down there. The C-130 has what we call wet wings, so the wing structure is the fuel tank itself, and that means that every joint, every rivet line has to be sealed and inspected and have sealant replaced and repaired regularly. All of that is hands-on labor. So every single day, there's about a couple dozen maintainers at Warner Robins just working C-130s that are going to crawl inside a wing fuel tank and do sealant repair. They'll do inspections, they'll do work on the plumbing, the hydraulic lines and the fuel lines, the electrical lines that all run through that fuel tank. It is a tough environment to work in. So I've been in a wing fuel tank myself. It is dark. You wear a headlamp in there because there's no light filtering through. It smells like fuel.
Yeah, that makes sense.
They drain the fuel out, they run purge fluid through it, and they kind of try to mop it up as best they can, but it still smells heavily of fuel. It's extremely cramped in there. So depending on exactly which space you're working in, you may only have a couple of feet, just enough room to kind of wriggle your body in without even really being able to crawl properly.
So it's not for the faint of heart, that's for sure.
You can't be claustrophobic and do this work.
What kind of gear did you have to wear?
So it depends on the stage of maintenance that you're doing. So when it kind of first shows up and there's still a ton of fuel around, they'll wear a full Gore-Tex suit with a hood and a full face mask. But by the time you get to kind of the later stages of maintenance where I was more engaged, the fuel's out of it, there's no real risk of explosion. So at that point, it's safety goggles, earplugs, headlamp, and that's really it. They might wear a Tyvek suit, that's just a real thin, disposable kind of coverall. But in terms of other safety gear, there's really not any required right now. And the good news about this is, the Air Force does this type of work very safely. Incidents in confined space work are very rare. The processes that we have in place now work well for making it safe. It is not fun, though. It is a difficult job. It's a painful job. I can tell you, I'm a little bit on the taller side myself. For me, getting in and out of those spaces, I came out scraped and bruised, and it left me with tremendous respect for all the men and women who do this work every day. You know, they are critical to keeping the Air Force flying, and they endure, you know, the darkness and the bad smell and the pain to keep our aircraft flying. So it kind of gave me that additional motivation to try to deliver a good product, you know, to make these guys' lives a little bit easier.
And what actually have you and your team done to make their lives easier and safer?
So we've been developing and demonstrating the confined space monitoring system, which includes some wearable sensors. So we've got some vital signs monitors that go on the maintainer themselves. We have an armband that we kind of adapted from smartwatch technology that provides communications, user interface, alerting to the individual that is inside the tank, and then everything else is outside the tank. So we use smartphones to relay data to a cloud server. That cloud server then can provide situation awareness and continuous remote monitoring via a web interface to a remote safety attendant, as well as to floor supervisors, even the fire department. So, you know, one thing a lot of people may not know is if there is an incident in a confined space, the other workers are absolutely not to go in after them. You know, that could turn into multiple injuries instead of just one. So the fire department is trained and equipped to respond to an incident in a confined space. The upside is, they've got the training and the equipment to do it safely. The downside is it takes that much longer to respond to an incident. So part of what we're doing with the confined space monitoring system is we give the fire department a situation awareness display. So they know all of the entries that are going on. They know exactly where and who. They also have the vital signs information so that if something is starting to go wrong with somebody, it gives them a little bit extra warning that turns into a faster response time.
And that beforehand, how did they just contact the fire department then if something went wrong?
That's correct. Yeah, in current operations, anytime you're doing that type of confined space work, you have a safety monitor that's outside the confined space that you're working on, but has eyes on the access point that you used.
Okay.
Not necessarily you yourself working inside, but at least they can see where you went in. If they realize that something has gone wrong and you're no longer responding, it's their responsibility to call the fire department to respond. But yeah, there's a little bit of delay there. They got to get to a phone, they've got to recognize that something is wrong and make the call.
Because really, I'm just imagining, like, we send Kenneth in the size of a wing, and I'm looking at the end of it before this technology, this wearable technology, and I have to either, call out an audible to him, like, "Hey, Ken, are you okay?"
Yes.
And that was the mechanism to make sure that he's okay.
That is the current mechanism.
And then if he doesn't respond because he's passed out or anything that could have happened in there, then I need to go run and tell the fire department and then just wait.
That's it.
Because there's nothing else we can do.
That's exactly it.
But now you probably you can reach out to Ken if, like, you think his heart rate's low or high or his breathing too fast or anything like that.
We can use the watch to ping him and say, "Hey, are you still okay?"
That's great.
And if he doesn't respond, we get much more immediate. So that alert goes directly to the fire department. They know, again, where you are, who you are, and they have at least some basic vital signs information to have an idea of what's going on with you.
And say if I was in the wing, like, I'm able to use this device, like this watch, to check in and like click, say, "Hey, I'm fine," or there's ways you said, is there a way I can speak through it, or is it just?
We're still in development, but yes.
Sweet.
Yes, so if you're familiar with some of the Apple Watches and the Android watches, you can speak into the watch, and it's just using voice over IP technology. Yeah.
That's great. And have people that use this now, the other airmen, how have they responded to it?
Another kind of surprising thing for me, going into this work, I was sort of picturing active duty airmen, blue suit labor, but at the depots, the vast majority of the labor is provided by Air Force civilians, wage grade civilian employees. So with that, you've got a pretty wide distribution in terms of some younger folks, some older folks, men and women. And so there's certainly a diversity of opinion, but I think the most common thing that I heard was they very much wanted to start using the system as soon as possible, because even down at the individual worker level, they're concerned about turning aircraft as quickly as possible. They understand the need, they feel kind of the pressure to do their jobs well and quickly, and see the system as something that would help them do that. The other thing I'll say is, right now, fulfilling that safety monitor role, it's just another maintainer who's doing that. There aren't specific people that are set up to be safety monitors. And while you're doing that, you're not allowed to do anything else. You're not on your phone, you're not reading anything, you're not talking to somebody. You are supposed to sit there and just do the verbal check-ins with your person that's working inside. It tends to be boring. The guys really don't like doing that. They would rather be doing almost anything. And so freeing them up to do additional work is something that's really very appealing for them. On the concern side, there's always concerns about incidental medical findings. There's concerns about, okay, if I have to wear this sensor shirt, is somebody going to actually wash it before, somebody else wears it?
That's fair.
We are working through all of that. Those are some of the realities of fielding the system, is you have to have the logistics and sustainment for the system as well as the aircraft.
It's something that we haven't touched on yet, but how hot can it get in those wings?
The hangar bays are all kind of wide open. They're not really air conditioned, so it's whatever temperature it is outside. So it can get, Georgia in the summer, it can get 90 plus degrees, high humidity. So another kind of surprising thing for me is the guys told me that when it gets really hot outside, they'd rather be working in a confined space than not, because they can pipe in air conditioning.
That's a nice bonus.
So the tank may smell bad, but at least it's cool inside.
I think they deserve that. Going in there, at least you have one luxury.
Absolutely.
And touching on what you said earlier about a lot of the updates here, where do you see this kind of going in the future then? Because you said we're going to be able to monitor these people in these wings, make it a lot safer, and is the idea to, is it a two-man team now, you said?
It's basically a two-man team. In the future though, we see this as a platform capability that we are fielding with the maintenance depots first, partly because it's the largest concentration of maintenance work, so you get the biggest kind of immediate benefit from fielding the system. But with a proven system that's affordable, that's rugged, that opens up a lot of other possibilities. So we are looking at then expanding the system to flight line maintenance down at the squadron level. So you wouldn't necessarily get the benefits in terms of labor savings, but from a safety perspective and an individual performance perspective, the guys who work on the flight line, absolutely, heat is a huge problem for them. So, we have a lot of bases in places like Luke and South Texas, where it'll be over 100 degrees, and they still have to get their jobs done, on those days. So
And on asphalt, that's probably even warmer.
That's baking hot, absolutely true. So being able to monitor from an individual level, okay, what's their core temperature right now? Do we need to pull them and sit them down in the shade and give them some water so that they don't become a heat casualty? That's tremendous benefit to the Air Force. The other thing we're looking at is more industrial maintenance. So something else the Air Force does is we maintain facilities, we maintain industrial plants. So for example, earlier this week I was out at Tinker Air Force Base. I was looking at how they do propulsion maintenance, engine maintenance there, and they've got mills and chemical washing and plating lines and a lot of industrial capability, all of which has confined spaces associated with it, whether it's under the machine or inside the machine. We've got workers in and out of these all day, and it's difficult work and it can be dangerous. So having the system available for people doing that type of work just gives you that extra safety margin to ensure that we are absolutely taking good care of our people.
And to help, something I was going to touch on earlier, to kind of give an idea of how common this is, you mentioned, let's say for a C-130, how often do they need extensive maintenance like this? Or is it just, like you said, checking, it's pretty common just to get in there to make sure everything's all taken care of and sealed?
Depot level maintenance, some of it is scheduled and some of it is irregular. If they do have significant damage, it may require depot level repair. off the top of my head, I'm not 100% sure what the scheduled maintenance looks like.
Yeah.
I would guess every few years, give or take, it's going to need to come in for that. But
Yeah, it could be like flying hours, or
correct.
or an actual. This has been this many years, and we must check.
That's
sort of
right.
stuff, yeah.
That's right. But at any given time, there's probably, if I had to guess, on the order of 20 to 30 aircraft in work, at Robins, just in the C-130 squadron. And then you can multiply that out by, there's also C-5, there's also F-15, and C-17, also at Robins. So, and that's just Robins.
Right, then you have
there's 3
Tinker
maintenance
and
depots.
Ogden, in
yes.
Utah and Oklahoma. So
It just goes to show.
they're keeping these very old and newer aircraft flying there. So
Yeah.
a lot of workload.
Absolutely, yeah.
Yeah.
So I can see why, for our viewers especially, why this is so important, because most people, even when I started, had no idea how important those confined space work, how it is, or what it really entails.
Especially in the early goings of the project, it surprised myself and a lot of other people just how much hands-on labor is required even at the depot. So when we started talking about, okay, getting inside a fuel tank just to do inspections, it's like, don't we have like robots for that? No, we don't actually. There is a lot of work on robotic maintenance, but we're still trying to really get that technology working well outside the aircraft. Getting it to work well inside the aircraft is going to be kind of the next step.
Yeah, it's a whole different beast from what it looks like.
and kind of touching on your research into these wings, we heard that you had a special delivery to Wright-Patterson Air Force Base to help you with your research.
So that was one of my proudest achievements as a lab employee. So after several months, I think, of trying to figure out, well, let me back up a little bit. So going into the Confined Space Monitoring Development Project, one of our biggest concerns is we need to make sure the system works well and reliably, even before we take it to the depot environment, because we didn't want to waste everybody's time, take away from actual maintenance work with a system that we didn't have high confidence was going to perform well. So we needed a realistic testing environment, and after looking around Wright-Pat for anything and everything, we talked to the museum, we talked to the reserve squadron. We kind of came to the conclusion that we were going to have to come up with something on our own. And so I found the right form to send to Warner Robins, actually, through the C-130 program office to get them to ship me a dead wing. So the wings are a hours limited part on the aircraft. Once you hit so many flying hours, they have to be pulled and replaced. And at that point, it's scrap aluminum. It goes to DLA for disposal. Basically, it gets auctioned as bulk aluminum scrap. So I found the shipping requisition form that said, hey, instead of sending it to DLA to be sold as scrap, can you ship it to Wright-Pat? I sent the form, and they told me, great, we'll let you know when it's on its way, when it's actually shipped to you. There was a little bit of delay in that notification, and I was actually on leave and out of cell service when they called, so I didn't get that call. And so it was kind of a big surprise to a lot of the lab folks when a flatbed with a C-130 wing on it showed up at the gate, wanting to know what they should do with this thing. So I'm very grateful. A couple of my coworkers kind of picked up the ball and ran with it there. And we got it dropped in a parking lot while we figured out how to actually get it inside the building. But yeah, we ended up putting it on a trailer. It went into one of our buildings in the 711th Human Performance Wings, and we set it up as a test capability that allowed us to do fully accurate confined space maintenance testing. So same tools, same environment as the actual maintenance, but something we could do ourselves without interfering with the work these guys are actually doing. So I've got a couple pictures of me sitting on top of a C-130 wing out in the parking lot of one of our buildings, and that honestly was one of the proudest days of my Air Force career.
I bet. Yeah, we're going to have to get a copy and share it with our viewers.
Please, that'd be awesome. Because that's not something people imagine. Like, I didn't even know you could request or deliver that. I
think I'm like most lab employees. I sit at my desk and I try to answer emails and I try to do my PowerPoint and my Excel spreadsheets, but one of those PDFs I filled out turned into a C-130 wing. So
That's great. That's great.
a little more exciting than my usual day.
So that actually, that ties into a question we had, speaking of ordering wings and doing fantastic things. I rhymed, I like that. But working with that, how would, let's say, a cognitive psychologist or somebody in your field get to this point then? Like, what advice would you give them?
The labs is kind of a unique in a way because there's no kind of one set path of, I want to get, to become a product line lead, or I want to be a CTC lead, or I want to lead a division or a directorate. I think there's multiple paths that get you from here to there. For my path, part of it was, having a basic set of technical skills, that I had been trained in, that I kind of honed in several years of essentially bench work for the labs. But after that, being flexible is the biggest thing. So I think where we work in the research labs gives us the opportunity to move between multiple different worlds. So especially earlier in my career, I was very engaged with university research, basic research, academic conferences, kind of trying to keep tabs of what's going on in my area of science. But then on the other hand, also having the opportunities to visit operational bases, to talk to pilots, to talk to maintainers, to understand kind of their perspective on the world, how they work, and what the opportunities for us as a lab are to provide the technology that makes them more effective and safer. So I took a number of opportunities, even relatively earlier in my career, like the C-27 work that I mentioned, to get some of that operational exposure. And I think that really set me on a growth path to where I am now. So I moved from a bench level researcher to a research team lead, then to a project manager type role. And then where I am now as a product line lead, I have multiple projects that are ongoing, multiple products ongoing. I work with the project managers that are under me and kind of apply the skills that I've learned over that kind of growth path of how to create and manage a research project, as well as having the technical depth to understand what's going on, what are the technical options, and how do we cope with setbacks and challenges, because anytime you're working research and development, there are going to be setbacks and challenges. Things will never work out exactly the way you envision when you start a project. So the persistence and the adaptability ends up being key to working successfully.
That's fantastic. That was a really good blurb there for, really just getting yourself out there, being flexible like you mentioned, and don't be afraid to try new things.
Absolutely.
And a question we usually like asking near the end is, do you have a favorite piece of Air Force technology, either in history or that you worked on, and kind of with that, a favorite researcher, maybe, that's helped inspire you?
That's a good question. Okay. I guess if I had to pick, one piece of general sort of Air Force technology, I was and am a huge fan of Kelly Johnson and the kind of classic skunk works. So the F-117 through to the early kind of stealth work, just amazing stuff. And to me, kind of an inspirational example of it. All it took was one person reading an obscure Russian journal of mathematics on wave propagation and scratching their head a little bit to say, hey, I think we could predict, how radio waves scatter off a surface, and we could use that to make an aircraft invisible to radar. Amazing. That's what I think. That's when AFRL is at our best, is when we take something that's kind of basic science that has no obvious application, and we're able to connect that to a capability that's absolutely game-changing for the Air Force. And the way those guys did it is way cool. I mean, Kelly Johnson, University of Michigan grad, as am I. So
he's beaming right now. You can't tell, but he's really proud.
There's some pride there. I can fully admit that. But that same kind of spirit and that same kind of culture of being open to new ideas from everyone, trying things out, being willing to accept some more risk, testing things earlier in the cycle, some of the spirit I think that Kelly and Ben Rich, built in the Skunk Works has really very direct implications for how we do work at AFRL, and I'd like to think that we've adopted some of that. I think some of our successes, can be ascribed in part to building a culture where we're tolerant of risk, and we're open to new ideas, and really support our younger scientists and engineers and give them the chance to try things.
It's great.
That's awesome. The last thing we had then was a fan question we got on LinkedIn. We had a fan wondering, with confined spacing, is that something that can be extrapolated or is eventually going to be used in space? Because I know that's kind of a big concern with how cramped that can be.
That's so funny that should come up. I do actually have a small project that is joint with NASA. NASA does routine vital signs monitoring on astronauts right now. That's primarily medical technology. It's a little bit tough to use, and they'll have physicians basically monitoring that data and doing interpretation. But what NASA's thinking about is that works fine when you're talking about somebody in Earth orbit, where you've got nearly instantaneous communications and you've got a lot of people working all the time on it. They're thinking about long duration space flight. They're thinking about Mars, they're thinking about moon base, where you might not have the whole team of physicians available on call all the time to monitor that data, and you might not want to use the kind of medical technology that they do right now. So they're trying to develop wearable vital sign sensors that are more comfortable, are easier to use, that might have some of the built-in algorithms that can kind of tell you how you're doing without requiring a full medical team to interpret it. We've been working with NASA to do some joint testing, kind of some early stage evaluation of company coming out of a small business. So this is Small Business Innovative Research, SBIRS. It's a great way to try something out. So small company out of the Boston area had a cool idea for how to do wearable vital signs monitoring and core temperature monitoring that I thought was worthwhile. The folks at NASA thought had application to long duration space flight as well. So we went in together, funded it, have been doing some testing, and that work is ongoing right now. Yeah, if we start thinking about Space Force and we start thinking about people in space more in the future, having ubiquitous monitoring technology, whether it's derived from the confined space monitoring system or not, is going to be essential to ensure that they're able to perform in that very challenging environment.
That makes sense. That truly you could say with this, the sky is the limit with confined spacing.
That's great. I like that.
Go trademark that out.
Yeah, I think I need to now.
Well, Dr. Christensen, thank you for your time, giving us a peek into some of the great work our Human Performance Wing is doing to keep our maintainers and even your work into possible space implications. So thanks for your time.
You're very welcome. It's great to be here.
And to keep up to date with future and past podcasts and to check us out on social media, make sure to see us on Facebook, Twitter, LinkedIn, Instagram, and YouTube at AF Research Lab. And make sure to stay curious.
Logging off.